Yeah, what they normally see, or they will see, is that sometimes it deflects negatively and positively, right? Okay. And I also say, okay, hang on, because now it looks like I'm just touching all of them at random.
Right.
Can we just now choose one as a reference out of these now?
So now the question of a reference and everything being compared with a fixed reference.
Yes.
Another very important concept.
Yeah. So what I normally do, I request them that, okay, let us choose lead as a reference, because lead is also available in my school. So when we choose lead as a reference and we connect, or we measure them with reference to lead, that is where now we can see that difference now with respect to lead. Okay. How is the deflection now with respect to lead? And some will be deflected negatively. And at that point, that is where now I allow them to record down what they see there. Okay. Right? They can just record them at random.
Are you at this stage already starting to talk about the size of the deflection, or are you still just looking at positive, negative?
Yeah, when they are recording now, that is where now I want them to have those figures so that you can talk about the size of the deflection, whether it's large or
less. So relative to lead, how willing is something to give away or to take electrons, that kind of discussion.
That's the thing, yeah. Then now, because the main thing about the lesson, of which I think that's why maybe it won, I also involve the learners in my lesson, because I can just show them at first connecting lead maybe to zinc.
So you have the kids crowding around you, and you have the set up, and then they can play and write.
Yes, then I allow them to come and they touch different metals, and they also record. You see, it's very important that they record. And after they've taken all those recordings now, then I allow them now to arrange them in order now, because some of them will be negative, some of them will be positive. So it's important now to arrange them.
Now you're saying, okay, there is lead, and then you're saying everything that deflected negatively relative to lead, do you put above or below?
Yes.
And then those that deflected positively, you would say put below.
That's it.
And so now you've got your order.
Yes, because they also do mathematics. They know the number line, that the one that is in the middle.
So you're relating it to a number line.
Yeah, because integration is part of NCS. It's also very important that you need to integrate with other subjects now. Yeah. So when they record now, they also get that chance now to remember that we need to arrange them in order of ascending or descending. But as lead, then I used to ask them, what do you think is going to be the potential difference or the reading for lead at this stage now? Because they can see that all of them with respect to lead, or as lead as the reference metal, so lead should be 0. Because all of them are compared to.
So you actually, it's not correct in terms of the table, but in terms of the concept, your reference level is 0.
Yes.
So if you choose another reference point, that becomes 0.
Yes. Okay. So because this is now a relative concept. So I'm trying to drive them to that point that right after they've arranged them now, that's where now we can say lead or zinc compared to lead has got so much potential difference now. That is now the difference between these two now. Then now they can see it's simple, because they can observe it and they put it on the chart or on the board, so that we can discuss it now as a group or as a class now. Then at that stage now, that is where now we can say, right, because we're doing this thing now in this class and we did not measure any conditions, we don't know today what is the temperature, we did not measure the concentration of this solution, you see, and we don't know exactly what is the atmospheric pressure as we speak, because we don't have all the equipment here. Because we're improvising, now I take them to that table. Let's take this table now, let's see something here. Right, let's try to compare this table that is in front of us, the one that you're having here, with what we have here. Then now I ask them, can you tell me which one here in this table is the reference metal?
So they'll find lead.
They will find lead. Lead, it's not 0 there.
Oh, I see. Yes. But so you're actually asking here what has been used.
Yes, what has been used. Which one do you think is acting like lead in this table? I'm sure now they will see that hydrogen is even, it's good in that table, it's even bold. You see, they can see it nicely that, it's 0.004. Oh, hydrogen is now the reference here.
That must have been used as the reference point.
Then hydrogen is the reference according to this table.
Okay.
You see, we're trying to compare with what we have now, right? And also, I can take them to other metals like zinc. Can you see zinc? Then they can detect, or they can see zinc there. I think it's about 0.76 volts.
Minus.
Yeah, minus. Yeah, 0.76. Yeah, they can see that. Zinc compared to hydrogen now, it's 0.76. Then I can just direct them to different metals, the ones that are positive and the ones that are also negative.
Let me ask you a question. The kind of measurements that you're doing, the very rough readings that you get, does that give you some idea of the potential difference between different metals and in contact with their ions? I mean, we're not even using lead and lead ions, we're just using lead and sodium, ions.
Yeah.
But those differences on your little scale, are they similar to the differences? I've never actually done this. So are they similar to the differences on the table itself?
No, they are not similar. That is where now I'm going to ask them exactly why maybe it's different.
Why the difference?
Yeah, why
come back to the standard conditions.
Yes, then we come to those conditions now that, here, this table now was established under certain conditions now, not the conditions at present.
Very stringent sort of
yes.
SA Bureau of Standards kind of conditions, exactly.
Exactly,
right.
Yeah. Then now we come to the condition like the temperature was 25 degrees Celsius.
But you're covering an enormous amount of conceptual ground in this one lesson. The notion of a standard and a reference point is not something that only applies here. It actually carries over to other areas. Okay.
Because what I like about the lesson, it's very quick. Because once you've assembled, you take maybe about 7 minutes to allow the learners to keep touching, and they record at the same time. Then, whilst this is new and exciting, because science has to be fun, that is what I've also noticed, that when you make it more fun, they tend to like it. And you compare something simple.
But also when they can understand it. And I think, that's something we shouldn't underestimate here. They're getting this very first-hand look at something that looks like a very abstract table. You're making it real.
You see.
That's wonderful.
Yeah. Then that's why now I'm going to tell them that, somebody who did this table now, did the table under these conditions now. These are the conditions now. Now, because we can't maybe meet these conditions now, then we need to use this table now because it was done under standard conditions. That is why it's called standard reduction potentials.
You don't have to do it all yourself, as long as you know where it comes from and you can see that there's a reason for it being like this.
That's it.
You can trust it.
Yes.
Okay. Now, you must obviously take this lesson and milk it over the next few weeks. I mean, you can always refer back to this whenever you use the table.
Yes.
How many more lessons does it take you to get the learners using the information on that table to solve problems, find out cell potentials and so on?
Yeah, a lot of lessons. For example, because what I've noticed is that my learners now used to fail chemistry. They don't have a problem with physics. I think maybe because they also use maths, they calculate. But now you see a lesson like teaching them the transfer of electrons, because that is the key thing now. That these half reactions now, there's a transfer of electrons now. In other words, we call them reduction or oxidation half reactions now. There is a transfer of electrons now. It's also very important now to understand exactly that, for example, zinc loses electrons now when it is compared to copper. It will lose electrons now to copper ions. So they can understand that one. That is another lesson now that we can embark on at a later stage.
There's probably a couple of weeks worth of lessons that will keep referring back to this basis, and always then consolidating and reinforcing.